Do you want to be able to make your own dazzling holiday light display? In this video, I'll show you how to set up LED lights that can be controlled by a microcontroller, creating a custom light show. I'm Katrina, an elementary school teacher teaching grades 3 to 5 students about coding, data analysis, and digital design. The first thing you'll need is a microbit V2. It's a small, accessible microcontroller great for beginners. Since this activity was done right before the holidays, I picked up some wooden decorations like houses, fences, and trees from the dollar store. These make for a festive platform to display your LEDs. I also picked up some epoxy glue to attach the decorations to the platform. Getting the LED light strips to stay on the house was unexpectedly tricky. I tried glue, tape, Velcro, and even epoxy, but nothing worked. Until Gorilla Glue saved the day. If you're doing this yourself, I'd recommend starting there. For the LED strips, I used a WS812B RGB model that I ordered on Amazon. I also ordered a separate 5-volt power supply to power the LEDs since I didn't want it getting powered through the microbit itself, and I got a DC barrel to screw terminal adapter for easy wiring. Lastly, I got some alligator clips to connect the microbit to the LED lights. If you're curious about how I've connected all the components together, I've drawn a diagram that you can look through here. Now that the hardware is sorted, let's jump into programming the lights. The primary reason I chose the microbit is that it's age-appropriate and accessible. Most of my students already know block-based coding, so their prior knowledge transferred seamlessly to this project. First, log into MakeCode and create a new file. Then you'll want to go to the Extensions tab so that you can import the NeoPixel extension. This will allow your microbit to communicate with the LED lights. Once you've downloaded the extension, you can click on the NeoPixel tab and drag in the block of code to let the microbit know that you have some LED lights attached. In my case, I have 60, so I'm updating the number from 30 to tell the microbit that we have 60 lights. Since I physically attached the green data in wire with the alligator clip to P0, I don't need to change the P0 in the block-based code, since that is where it'll get the information from. The other two blocks that I'm dragging in are just to reset the LED strip once the program is run. Now, let's quickly talk through some of the logic of our program. We know that the lights will change color with each music note, and the notes will play for a specific length of time. We also know that the light color will synchronize with the notes. To handle this, we'll use something called a function. I explain function to my students like this. Imagine ordering chicken strips and fries at a drive-thru. You tell the kiosk your order, which is the form of an input, pay, and then receive your food, which is the output. In programming, a function takes inputs, performs actions, and returns outputs. In our case, the inputs are a music note, how long to play it, and the color for the lights. The function plays the note and changes the light color accordingly. To create this, I went to the Advanced tab and added a new function called playNote. I set the inputs as numbers for the note, duration, and color. Next, I experimented with calling the function by translating the notes for Jingle Bells into MakeCode. This involves some trial and error by toggling into JavaScript to better understand the function calls, and to get the timing of the notes just right. Once the code was ready, I plugged the microbit into my computer and downloaded the file. The last thing to do is to give power to the microbit by connecting the battery pack. And voila, the lights dance along to the music. I also printed out sheet music for the holiday songs so students could try their hand at reprogramming the lights with different tunes. I was so excited and wrapped up in what my students were doing that I completely forgot to record a video of what they worked on. But my coworker snapped this photo to show on the school's social media. I hope this video inspires you to try your own LED and microbit project. This was my first hands-on electronics activity, and it was such a rewarding learning experience for both me and my students. If you recreate this project, please tag me. I'll leave the links to my social media accounts in the description. I'd love to see your version of it. Happy holidays and happy coding!